friend, so to say, but still young, as I see, at our seminar. And so I also welcome all the regular participants, and as of course also those who just were attracted by the title and came only for this seminar. I hope you will find it nice and rewarding and come next time as well. So, Martin Čmejrek, our former student and now a researcher, a leading researcher, can I say, in the IBM company. And he will speak about the machine translation system. So welcome, Martin, and please, the floor is yours.
Oh, thank you very much, Eva. Okay, thank you for mentioning old, because if I have to describe myself, I would say that I am already a dinosaur that once happily roamed the aisles of your department. I think I started to happily roam 25 years ago when we started to work on English Czech, or when I started to continue the work on English Czech machine translation. That was when I started collecting data, collecting the parallel data for Czech English. And since then, I basically stayed in the field of machine translation. So I happily roamed the aisles of UFAL department till 2004, I believe. And then I left for IBM to do chatbots and interaction with using speech with automotive, with car controls. That was from 2004 to 2007. But then the opportunity showed up to start working in IBM in Yorktown Heights. And that was in the very early era of speech-to-speech translation. So, you know, this is probably older than that, but this was like 1980s imagination of how a speech translation device could look like. And in 2007, or maybe 2010 to be precise, we got to a very similar stage, except that there were two devices, where in IBM, under a DARPA research project, we managed to get speech recognition and machine translation and text-to-speech synthesis on a single device. In this case, this is iPhone or the Android phone. And what's interesting here, that all the machine translation, all the speech recognition, translation, and speech synthesis actually happened on the device. So there was no communication, no network communication needed for that. So all the system was heavily optimized for low footprint and you know, bearable latency. I came back to Czech Republic in 2012, and I joined Prague Research and Development Lab that later on became part of Watson AI group. And among these people, you can still see some of your colleagues. For example, Jan Cuřín is here. If you remember Pavel Květoň, we can see him here. And Mirek Vodolán is probably where everybody has the participants of this call, so he's hidden here. This is Michal Bída. I think that he's from the faculty, the mathematical and physical faculty as well, and probably others that I forgot. Okay, so I'm sitting on two chairs. One chair is the chair in Prague, but on dotted line, I work with people in Yorktown Heights. Salim Rukos. I'm showing this this famous paper about the blue evaluation method. So one of the authors, Salim Rukos, used to be the lab director, and Todd Ward is my current boss in the United States. Recently, Salim retired from leading the lab, and for those of you who remember Radu Florian Hans from Johns Hopkins Times, so he's currently leading the MNLP group in Yorktown Heights. So this was here is the outline of my talk. We did the archaeological findings of the dinosaur that once roamed your space. And now let's go to the real work. So it will not be about speech translation, it will be about translation. And my current machine translation work happens in IBM Cloud, and it's a part of Watson language translator service. So then I will talk about some field that we share in common. I know that we were kind of competing with Andrzej Bojar and his team on a translation of technical documentation. From last time, I remember that you guys beat us on Japanese, and we are maybe slightly better on Czech English translation in that technical documentation domain. So I have some problems that we see, and I have some experiments that I tried, just rough ideas for those experiments that we tried for this field or for this set of problems, and we may discuss them after the talk. All right, so let's look at the IBM Cloud and the Watson language translator service to give a bigger picture. So IBM Cloud is an environment where you can satisfy most of your needs, provided that your needs are to get computing power, storage, and AI services. So you can easily get free account on IBM Cloud, and until a certain volume of work, you can get a lot of work done for free. Of course, we want to sell it, so we hope that you will want to do more work and that you will have to start paying for that. So, but to get familiar with that, you can run pretty easily for free. So there is a catalog of things that you can get there on this IBM Cloud. So let's look at services. You can get there hardware, you can get their computing power. I just hope that you can see my browser and that it's still readable. If not, Andra, let me know, please. So you can get their computing power. You can get there also storage, and you can get there services. So you can search for translation. You can see language translator here. So this is the service that I'm working on. And this is delivered by Watson. So here is the Watson web page that lists the services that you can use. On the first, the first group is our tools. that you can use, such as Watson Studio, Watson Machine Learning, etc. The second tier is applications such as Watson Assistant. This is basically a chatbot or tool for creating a chatbot, Watson Discovery for data analysis. And then you have services. You can see that pretty much of those services are related to NLP. So there is Watson speech to text, basically ASR, speech recognition. Watson text to speech, TTS. Watson natural language understanding, that means morphological analysis, parsing, entity extraction, named entities. This is, I think you had the talk of from Honza Curin, so he was probably describing this part as well as the Watson Assistant part. So this is his field. Watson Knowledge Studio, this is about, well, expert knowledge, and this is a service to extract relationships between entities and learning some representation of expert knowledge. Visual recognition, Watson Language Translator, language ID. So this is basically you throw a text and it will tell you what language it is, some probability distribution. Personality insights. So these are some psychological personality insights given written text. And Watson Tone Analyzer, this is some tool which is designed for call centers that detect emotions of the calling customer. So our talk will be about this tile, the Watson Language Translator. So it's, well, there is nothing complicated to describe about translation service, how it should look like. Most of translation services look the same. So what it offers you, one thing is the language detection, so that if you type hello, it will think it's English with very low confidence because the text is very short. As you keep on typing, the confidence gets much higher, and you can translate it. You can select the number of target languages. So hopefully the translation to Czech will be correct. So this is the translation demo page that looks pretty much as you would expect. And in addition to that, we have API that you can use through the IBM Cloud. So let's look at the API. There is some documentation in IBM Cloud that you can later read on. Basically, it works like that. You will create your account in IBM Cloud. There you can generate your authentication certificate, and from then on, you can start using the service. So probably the best thing is to show for real how the thing works. So I have prepared here some cheat sheet so that I don't have to invent the API calls by myself. And so first of all, you would like to know what language pairs are supported. So you can ask for that. You get a list of language pairs that you are supporting. So provided that you want to write some application that will use the IBM language translating service, this is the way how to query what are query possible features, possible language pairs. So there is the source language code, the target language code, and the some other parameters about the language pair, such as whether words are separated or not, such as in Chinese or Korean, what is the writing direction, and other features. If you want to translate some simple sentence, there is an example how to do that. So doesn't look good. You can get JSON response with the translation. So basically on the command line, I have specified that I want English to check model ID, and that I want to translate some hello world sentence. And here I get a JSON response with the check translation. There is also a possibility to translate whole documents. This used to be a unique feature of this IBM service. Now I think that the other manufacturers are also providing this feature. So this allows you to use your document in 30 different formats that you can think of. So we can do Microsoft Office documents like Word, Excel, PowerPoint, Open Office documents. We also support PDF in experimental version, but this is really experimental because extracting the biggest problem in PDF extraction is the actual extraction of the source text, because it's not guaranteed that in PDF the text will be stored sequentially. So basically, it's almost as difficult as doing the OCR from a printout. So let's suppose that you have some presentation. Let's try to translate some document. I have prepared some sample presentation in PowerPoint. So this will be the title of our presentation, Food for the Translator, with some subtitles, with some formatting, with bullets and pictures. And the way to translate it, you can use this API command. You can upload your presentation to the cluster. So let's do that, because then we will have to wait till the system translates the document. So currently we have uploaded the PowerPoint to the server, and the status is that it's processing. Sorry. And later on, we can get the translated document, download it, and look at the result. If you upload the document, the server gives you some ID under which it is registered, so that you can download it later. And our fresh copy is here. But something went wrong with my computer, because I'm still showing, because I'm not seeing my mouse, which will be pretty tricky to show anything. Okay. Hey. This doesn't look good.
Every now and then we do see your mouse, so
Yeah,
only
But
if it's
we
only
also
us who
see the we
yeah,
also
then we
see
can.
the file size, and it's 100 bytes.
yeah. No, the problem is that the PowerPoint file does not open. It's probably, well, anyway, now you have to believe me that you will see that the result contains a translated output while the formatting is preserved. And there was actually a joke based on some translation error, but you know, I believe you are not sleeping after your good lunches, so let's skip the joke.
Can you open that file in just plain text editor, because it's too small anyway? So I guess there's probably some headers missing, and maybe
Yeah.
the plain text source will actually disclose the translations.
Yeah. Well, but you know, the joke was not that much, you know, that much good. So I think we can skip it anyway and continue with the presentation. Maybe in the discussion I will try to recover that. So this is basically what our service offers. So okay, so we have shown the demo. We have shown the APIs that you can access in the that you can use to, you know, start using the service. And there are other functions described in the API that are available for customers, and these functions are made for customization. So you can create your own models in this service. There are two ways how to customize your models. One way is forced glossary. So this is when you are translating some text with a terminology. You can enforce certain words to be translated always as you request. Of course, you can see all disadvantages of that approach, such as you know, poor functionality with morphologically rich languages. We can get to that later in the discussion. And the second possibility to customize your models is corpus customization. So this way you provide a TMX file or any other format which is described in this list. You can use other formats, and the system, the service, will start from the base models and will run some additional rounds of training on that TMX file. I forgot to mention that your TMX file is supposed to contain your domain-specific parallel data. And it is quite efficient for like tens of thousands parallel sentences from your domain. So in general, the general models are trained on tens of millions of parallel sentences. And if you want to adapt these general models to some specific domain, you should provide like 30,000. You can provide up to, I think, a million parallel sentences, but think it will start working when you have like 30,000 parallel sentences. You can start, you can run your domain adaptation, and the translation model will adapt to the domain of your that you need. and then the API contains some commands to handle, to control the life cycle of your models. So this is basically the main functionality of Watson language translator. Now let's go back to the presentation. So I assume that you will have questions as to what is the technology behind the service and how things are done. So this is what I will tell you. So we use PyTorch modification of training pipeline for the general models. Then for the production, we use automated pipelines that build models automatically from your training data. I don't know if you are familiar with CI/CD. CI means continuous integration and CD means continuous deployment. It basically means that if you change the training data or the method, let's say you change the training method or the decoder method. So continuous integration will try to build the models from your training data using your most recent method version stored in GitHub, and it will perform all the tests. And once all the tests are, working okay without errors, you can go to the next phase, which is the deployment. This means that the models will actually show up for the public. So for customization, we use some IBM version of Jenkins pipeline, and for deployment, we also use Jenkins deployment pipeline that will automatically publish the models. We use cloud object storage for input and output data storage, and also for storing the training data and models. And we use IBM Cloud Kubernetes for cluster deployment. We can maybe later on in the discussion, go to details about that. The core technology is RNN. So we use RNNs with gated recurrent units. It's basically Kunyun Cho's approach. Later on, we can discuss why we are not using transformers as well. And so we are using encoder and decoder approach with attention. These are some benchmarks from 2018, actually, that compare IBM with competitors. But take it with a grain of salt, because this is really 2 years old. So here, on the X, you have the price, the affordability. On the vertical axis, on Y, you have the performance, which is not blue score, but it's HLEPOR. So this is the chart that puts us pretty close to Google. So this is some external evaluation done by Intento, like independent company 2 years ago. You can see that DeepL has higher accuracy, but at the same time, they have a smaller portfolio of languages. And this Microsoft point is actually, I think, before they applied the latest NMT technology. So nowadays, I would expect them to be higher, as also our internal evaluations show. And you can see the 2 bullets here. This is IBM before before deploying NMT models, and this is IBM with NMT models. And you can see other competitors in the chart. Okay, so this is something that we might use for discussion. Why we still use RNNs and what are the economical aspects of running translation models for profit. So these are, if you have text to translate, these are the prices that a translation company will charge you. So this is what you pay as a translation customer. It will probably, it depends on the target language, it depends on the domain, but these prices have not changed much during the last 20 years. So the idea of running machine translation for profit would be to use the power of machines and shave some dollars off the pie that is here. So these are the prices that the translation company charges you. These are definitely not the prices that a human translator can earn, right? So here are two other interesting bills or proposals. So this is what happens if you want to rent a machine on IBM Cloud. So this is a list price. So if you want to hire something with 16 cores and some small memory and some reasonable disk space and network traffic, you will pay like $400 a month to get that on IBM Cloud. And on the right side, this is the price list for what we charge for the translation, for Watson Translator, for the language translator. So you can get a free license that gives you 68 languages for free, up to 1 million characters per month. If you want to translate more, or you want to run your custom models, you will have to upgrade and start paying to us. You will get 250,000 characters for free, and you will have to pay 2 cents per 1,000 characters. I don't see actually what I have written there because I see the participants, but I think I know it by heart. And I think you will have to pay $15 for each custom model that you create per month. But of course, this is list price. In real world, there might be discounts. So in order to run this business internally, that means our translation group has to hire these machines and pay the costs for translating, for running the translation service. And it does not always, it is not always, not all the traffic is paid traffic. Most of the traffic is actually within the 1 million free characters. So most of the traffic is actually paid by us as the service providers, because we have to pay the hardware that we run on. So, for example, the search engines or NLU providers, they are running indexing and machine translation for purposes that do not require such high precision of translation. So they try to stick within the free limits. So the percentage of paid traffic is actually quite low. So this is some food for thoughts about the economical aspects of running translation for revenue. Okay, so this was about how this was about the public information on language translator. And now let's get to some problems that we face that are within the intersection of our efforts. So basically the translation of technical literature That's something that we worked in parallel with Andrzej and his team. So I think this is the playground, right? This is what the poor translator has to work with when they translate technical literature. And I think the competition was, this is a translation memory. So basically it's a database of translations done by the poor translator. And if the next translation is found in the database, the system will offer it as possible translation, or it can use some fuzzy match if the translation, if the source of the translation is very similar. So the idea was to use either UFAL or IBM system to propose translation in case there is no fuzzy match to be found or no exact translation to be found. I think that we even competed with fuzzy match. I don't remember the details of the competition. And the competition was that the tool offered, I cannot see the mouth again. So I think in the middle window, we have two competing proposals. One was the translation proposal from IBM, and the other one is the translation proposal from UFAL. And the human translation had to pick one of these translations, or if both of them were poor, they might decide to start translation from scratch. And based on this human translation interaction with the tool, we were evaluated, we were receiving points, or some precision metrics was defined that evaluated the quality of our translation. So basically the goal in the competition was to have as many successfully used translations as possible. So, you know, here one of the problems that our customers always complained about is something like the butterfly effect. So here I search for the original article about the weather predictability from 1972. So this is the cover of the butterfly effect paper. In machine translation, the butterfly effect might look like this. You have source sentences that look all very similar, and the butterfly wing change is here, for example, the number of the building, 4A, 5A, 15A. So from a human perspective, these should be, the translation should also look similar, but they don't. And the customers complain about it because, especially if these translations show up in a form of some directory, like phone directory, and you have them in one column, the translation really looks awkward. So the reason, we investigated the reason why the translations diverge so much, and it's somehow hidden in the quality of the bidirectional encoder. And it has something to do with BPEs. So each since the segmentation, the BPE segmentation of these words looks different, and each of those subsegments appear in very diverse context, that will affect the learned word embeddings, and it will influence the variance of translations on the target side. So that's one issue that we have. I will happily discuss ideas we tried to fix that. Another problem is forced glossary. So I touched this in the description of the Watson Translator service. So currently, the force glossary is a very stupid, I would say, tool that uses some heuristics. It basically follows the attention within the RNN model to track back the source to target alignment in the translation, and then it does word-to-word replacement. So, for example, if we go from English to French, the word-to-word replacement cannot get this right, can never get it right, because French is using the basically the word order is so that the adjectives are after nouns. So this is why we actually delete the number of the question. So one problem is that each translation uses different word order or has this butterfly effect. Another problem is that we delete the tokens here. So this is problem with force glossary. Well, problems with headlines. So this is not related to technical literature only, but headlines are always problem. I believe you must have a fix for that too, because all of these uppercase sequences are basically unseen words. So they split into too many low frequency BPEs, so that the translation does not make sense. So the solution that we chose is to encode the letter case as some special inserted tokens. And once we do, and use it for source and target, insert it into source and target training corpus, and then in decoding. And then we have some module that basically decodes or reconstructs the letter case back to the translation output. This is some fix that actually works. We have problems with Whitespace. So many of the technical, a lot of the technical literature that we translate is some form of markup, like HTML or XML, or basically the markup that the translation company is using to represent the translation and to represent the specific entities that the translation company is handling. So a lot of the traffic contains markup. So we have special treatment of markup. But one of the customer complaints is that the Whitespace is not Whitespace handling inside those inside the markup is not consistent. So currently we have some special handling of markup tokens, and we remember in each object the actual Whitespace properties to do it properly. Whitespace handled in post-processing is tricky, right? We have some rules that define the target language post-processing or target language handling of white spaces. For example, whether dash should be separated by spaces or not. But the customers, they want to have it as, according to their own rules. So we have systems that, handle this. But they are very tricky, and these are mostly heuristics. So what we currently are working with is that we learn the tokenization, and the tokenization also as some special inserted tokens. Basically, you can see some blue token that represents that there was no no white space between 200 and these 3 zeros here. So it's like 250,000. And we learn the tokenization and detokenization rules as part of the translation models. And it helps a little bit. Yeah, for Czech, we try to play with alternative segmentations. So not only as a baseline, we use the baseline BPEs from Rico Senrik, and we try to do something that respects more the derivative morphology of Czech, but we have learned the prefixes and suffixes by unsupervised way, and then we tweaked the BPE acquisition to respect those prefixes and suffixes. It gave us some slight improvement. This is term minus blue, so the lower the better. The motivation is that we believe that if the BP segmentation respects more, the linguistic boundaries, we might get better results and also limit the butterfly effect. So this was one of the experiments that we did on English to Czech. This probably belongs to that. We have ensembles of models with different BPE schemes. We are using RNNs, so it's easy to do ensembles. And again, the motivation here is that we believe that if each model in the ensemble will use a different BPE scheme, let's say learned on different domain of data, we will see more variation of BPE segmentation on the source and target, so that our system will be more robust to bad BPE segmentations, or those that we psychologically do not like. It's take it with a grain of salt, because everything is unsupervised here. But again, it shows up that if each of the models uses different way of doing BPEs, it can give you some improvement in automatic measures.
May I have a clarification question to this? So is it BPE on the source side only, or on the target side?
Both. Okay, so I think I know what you mean. So the alternative BPE on source side is easy, because you can have two different encoders, and even attention can handle that quite easily. On the target side, it may become more challenge, because with RNNs, you probably use beam search, so that hypotheses that compete with each other have the same length of tokens, right? So the same number of tokens, buckets compete. You compete within a bucket that all has the same number of tokens. So here we have had to modify the decoder so that the competition did not happen on the boundaries of tokens, but on the boundaries of whole words, which does not not that surprisingly, add to the complexity of the decoder. So let's say the whole code gets more complicated, but it's not more than 10% of time, because first of all, there is some zip law of distribution of words, so that not that many words are actually segmented into BPEs, right? So you don't do these special handlings of unfinished words too often. And And that's probably the reason.
Yeah, so I would be afraid of too many options for those few words which have to go through BPE, because then these different BPE segmentations could be possibly also mixed with one another, and that would give you an explosion of target side ways of producing the same word. So you're polluting your NBEST list as well.
Yeah. Yes. So we do. You know, I forgot that term from the SMT times, but there was something called recombination or something, right? So basically, we have the classes of identity, so that even you have a hypothesis with different segmentation, they are in the same class, so we recombine them, right? So you have to prune the
Yeah. Okay. Thank you.
The competing segmentations. So it's a lot of work. It complicates the code. It brings some improvement here. So it is actually, but this is my impression just from looking at the data, that it's more robust towards invented words. So sometimes, you know, the output sometimes invent words that do not exist in vocabulary, and this seem to help for reasons that we can discuss in the discussion. Okay, so here is another experiment. This is not in product yet. So forced glossary is substitution, is word for word substitution. So obviously Czech is a problem, as you can have other, you know, you can have competing target forms, morphological forms. You know, the original idea of the forced glossary was 100% recall when you do the replacement. So if you see the term on the source, you want to see the prescribed target on the target in the output, which is probably good for English and French and for languages without inflection, which is still a major, you know, volume of translations. But as we start supporting languages from Eastern Europe and other, we have to come up with solution that will work for them. So we will have to relax slightly on the condition of 100% recall when you replace the terminology, and do something like some heuristics that will tweak the beam search and basically boost the probabilities for hypotheses that contain the forced glossary as you prescribe in your TMX file, so that it will give them some advantage when they compete with the natural hypothesis that the system would come up with. And yeah, so this is some experiment that might show up in production for customers that deal with inflective languages. Oh, I'm at the end of the talk. It seems that I have deleted the conclusion slide, so even I was surprised myself. So thank you for your attention, and now we can discuss.
Well, thank you very much, Martin, for your interesting talk. I think we learned, or we looked at machine translation from still another perspective, and I think it's very nice to have also this kind of perspective.